we'll be seeing the meeting rooms problem and build a solution in JavaScript. Let's understand the problem statement before trying to jump into a solution. We will be receiving an input of intervals array which will be having each entry as a combination of two values. The first value is going to be the start time of the meeting, and the second value is going to represent the end time of the meeting. The aim here is that given the schedule of all the meetings, we have to figure out whether it is possible for a person to attend all the meetings or not. And that is the goal. We will either return true or we will be returning false, depending on whether or not it is possible to attend all the meetings. Draw it on the timeline and see how it looks. We have a timeline here represented by difference of 5. So this is 5, this is 10, 15, 20, 25, 30. I will chart this end here, which is going to be 30, and this is going to be the span of one of the meetings that we are going to have. And the next meeting that is going to be there is going to have a span of 5, 10. So it's going to be starting at 5 and it's going to end at 10, which is going to be here. And we have another meeting which is going to be starting at 15, which is here as 15, and it's going to end as 20. So these are the two meetings which are there. So now we can see there is meeting A, there is meeting B, and there is meeting C. Meeting A runs the entire duration of the timeline, while you cannot attend meeting B and meeting C because they are both clashing with the meeting A that we have. So it is not possible to attend all the meetings. Let's see another example here. We start with a duration which is 2 here. So I'll just mark as 2, and 4, 6, 8, and 10. It goes from, one of the meeting goes from 2 to 4. So I will start a meeting at 2, it goes up to 4. Another meeting starts at 7, which is here, and it goes until 10, which is here. So this is meeting B that I have. Now I can see that both these meetings A and B are not conflicting with another. So it is possible to complete all the meetings by one person, which is the person will be able to attend all the meetings. Whereas in the first case, I saw we are not able to attend the meetings B and C, because if you start attending meeting A, then the time gets consumed by A meeting itself. Now this is what we saw by drawing it on the timeline. Now let's break it down a bit further into what criteria made it possible for the meetings to be able to be attended. So in case of the second example that we saw, we said that user could attend both meeting A, let's say this is meeting A and this is meeting B. Both meetings could be attended because the first meeting end time, which is this is the end time of the first meeting, did not clash with the start time of the second meeting. This is the start time of the second meeting. So if we can say for certain that for the first meeting that we have, the end time, if it is less than the start time of the second meeting, if it is less, then we can say yes, it is going to be possible to attend both the meetings. But if the end time is greater, then you cannot attend both the meetings. So if it is greater of the first one, the end time, then the second's start, it is not possible to attend the meetings. So this is one rule that we established, and that's going to be the core foundation, wherein first we will sort all the timelines so that when we check for end time of the first meeting and the start time of the second meeting, I am sure that the timelines are aligned correctly. So I know that this meeting is supposed to go first and the second meeting is going to be following the first one. And To do that, I can just sort by the start time of both the meetings. So start time is in this case 2, in this case 7. So if I sort based on the start times and then I compare the end of the first meeting and the start of the second, and if it is not overlapping, then I can say that all meetings can be attended successfully. And that's pretty much it in terms of implementation. Let's go and see how it looks in terms of code. First thing that we will be doing is sorting the input by the start time. So we will be receiving this intervals input that we have. I will just say whatever intervals we have received, sort them by the start time. So that will look something like a of 0 minus b of 0, because the 0th item in the array that you have received is the start time and the first item is the end time that we have received. Next, what we will do is, after we have done this sorting, the main aspect of the implementation comes into play, wherein we will now check the current ones and the next ones start. And to do that, I will just run a loop which will go up to the intervals length -1. Why -1? Because we will go towards the end and only check for the next one. So when I am at the second last index, I will compare second last and the last. If I am at the last index, I am not going to check anything out of the bounds. And I will just say within this loop, perform a check. If the checks fail, then I will return false. Otherwise, at the end, I'm just going to return true, saying that I have been able to complete all the meetings successfully. Now, after this, what check comes within this loop of ours? I will take the end time of my current one. End time of my current one is basically intervals of I of 1. So this is the end time of the current meeting in the sorted sequence. If that value is going to be greater than the seconds start, what is the second one here? So if the intervals of I plus 1 start, so this is the second meetings start. If this is greater, then I will say meetings cannot be attended. In terms of the time complexity that is going to be involved here, it's going to be big O of n log of n for the sorting. And then we run a loop which will go up to length. Let's say if it is n of the meetings, then it will go up to n minus 1, and minus 1 being the constant, the time complexity there will be big O of n itself. But we know that the time complexity n log of n is far greater than big O of n. So in the end, the overall time complexity itself becomes big O of n log of n, because that value is very high. And in terms of the space complexity that is going to be involved here, it's going to be big O of 1, because we are just sorting and going through, run a loop with these intervals and then just doing checks. So no additional space is getting used, rather than just sorting and then running the loop and returning the status. And that's pretty much it. Thank you for watching. Please like and subscribe.